Please join me in welcoming Dr. Stephen Davis. Thanks for joining us tonight.
It's my pleasure. Thanks very much for having me. Well, thank you for that very kind introduction. And I'd like to also start by thanking Jennifer Clements and the team there at the National Academies for organizing this event and inviting me, giving me a reason to wear a shirt with a collar, and also to talk about some work that has been a silver lining for me and otherwise very tough year for all of us. Not just because emissions of CO2 have gone down this year, which they have, and I'll talk about, but rather also because the data products that I'll be talking about that we've developed this past year, I think are going to be very valuable in the years to come. So just to get into it and provide some background for those of you all who don't spend most of your time thinking about energy use or CO2 emissions. This is a plot that was published by a group called the Global Carbon Project back in 2019. And it represents a couple decades worth of annual CO2 emissions worldwide. So it gives you a sense of the trend that, since 1990, we'd seen a lot of increase in these global CO2 emissions from the burning of fossil fuels. But it also shows you in this last year, which is labeled in red, that as of the date that this report was published, 2019 emissions were projected to be slightly up from the prior year of 2018 by about 0.6%. The important thing I think that I want you to take away from this slide, though, is that this is a projection of 2019's annual total emissions worldwide, and it was being published by this group in December of 2019, so at the end of the year. And that's really historically doing pretty well. Many times in prior years, the estimate of an annual emissions from the globe didn't come out until maybe midway through the following year. And these emissions were typically based on energy statistics reported by countries and groups like the United Nations and BP, essentially based on how much coal, how much natural gas, how much oil was being burned around the world. They tabulated that up at the end of the year and made an estimate. And that was the way things worked. Another thing I wanted to note before I go to the next slide is that you can see this little dip here on the plot. That represents the global financial crisis began in 2008 and it really hit the emissions in 2009. And you can see, it's noticeable as a dip here. So from the same report, again, in 2019, we were looking at where these emissions were occurring around the world. So this shows the major regions of the world that were emitting at that time. And just to highlight the US, because I'll be talking more about that later in this talk, US emissions as of 2019 were projected to have decreased by 1.7% since 2018. And really that was part of a longer term downward trend, decreasing since 2010. Now, underlying that is just a long-term trend in a shift from coal to natural gas in our energy sector. And so that's what was happening in the US. So that's where we start. That's the context and the background of what was going on in the world of CO2 emissions inventories. And of course, as we all know, the world threw us quite a curveball beginning in 2020. And this is a nice picture, I think, to kind of give you a sense of how big of a curveball that might have been in terms of energy. This is a picture from Wuhan, China, of an normally very busy highway in late January of 2020 with almost no traffic at all. And a couple months later, the picture wasn't so different in Los Angeles, near where I live. Here in rush hour traffic on the left in March or mid-March of 2020, and then again a month later in mid-April, and you can see the dramatic decrease in the number of cars in the road. So if you're someone like me who spends a lot of time worrying about energy use and how we're going to reduce emissions, immediately those of us in this line of work began thinking, how is this drastic change in human activity going to affect how much energy we're using and thereby how much emissions of CO2 and air pollution are being created? And so, still getting used to the idea of Zooming and sitting on my couch, some colleagues and I started talking about all of the different ways that the COVID-19 pandemic was likely to affect different activities. Specifically, we were, of course, interested in the human health implications, but also in how the public health restrictions on mobility might affect economic activity and how much people were using cars and planes. And then in turn, of course, as I already said, those things will affect how much electricity is demanded, how much industrial production is going on to meet demands for goods, and how much people are directly emitting by driving their car or using heating and cooling at home. So we wrote this review paper, sort of reviewing in a conceptual way these interactions. But we were still grappling a bit with exactly how to go about quantifying those because, as I already mentioned at the outset, historically, we've waited until the end of a year and then figured out how the emissions changed in that year. We had very little experience making those kinds of estimates of changes in emissions at anything less than an annual scale. So another group of authors from the Global Carbon Project came up with a clever approach to estimate these effects on CO2 emissions using what they called a confinement-based approach. Essentially, they looked at what emissions had been in the year 2019, and then they looked at how different levels of confinement and public health policies around the world might affect those emissions that occurred in 2019. And they made some estimates, and you can see here the plot of global CO2 emissions, in this case plotted as daily numbers. And they found that at least at the peak of lockdowns around the world, say early April of 2020, that these daily emissions might have fallen as much as 17% was their estimate. Now, in comparison to the relatively small dip that I pointed out earlier from the global financial recession, which might have been 2 or 3% of decrease in emissions, this is a very large decrease. And so it was really powerful to see this out. In the meantime, though, some of us had an idea that was arguably less clever and more tedious, and that's what I'll spend the rest of my time talking about. This group of colleagues, including Ju Lu from Tsinghua University, Philip Sias from LSCE in Paris, and myself, started doing something that was a little harder, as I mentioned, and that was to go out and collect as much as possible daily or hourly activity data about all of the different things that were related to CO2 emissions. So, for example, we found some sources for detailed information of flights around the world on a daily basis, including what kind of aircraft, how far, where it originated, where it landed. We looked at ship traffic. We looked at TomTom's products for congestion in major cities, about 400 cities around the world. We found some information about actual traffic counts, where they monitor how many cars are driving over certain areas of highway. We found data in Europe and later in the US about pipeline natural gas deliveries to residential and commercial buildings. And then we collected from a range of power companies and power grids in different countries information about exactly how much electricity was being consumed and what sources were deriving that electricity. We also looked at weather data, and the idea here was to move away from these annual energy statistics towards something that could give us a clearer picture about how energy use was changing in what we would call near real time, so within maybe a week or two of the actual change. And just to show you a schematic of what ultimately we have called the carbon monitor, this shows some of those sources and how we manipulated them in order to make an estimate of daily CO2 emissions in different major countries. So you start here maybe in the upper left with industrial activities. There are monthly indices from some of the key industrial countries like China. For instance, China produces about half of the world's steel and cement. So that's a huge source of emissions. As I mentioned, electricity data could be daily, in some cases hourly, from different sources around the world. For ship transport, initially, we were using numbers from the International Maritime Organization and how that was being translated into CO2 emissions. Air transportation, as I mentioned, there's a company we found that we've licensed some data from called Flight Radar 24 that tracks every flight every day. For the road transportation, I mentioned we have 400 cities worth of data about congestion, and we also had data about actual vehicle counts. And we created a simple model to correlate those to make estimates of daily road transportation. And finally, as I said, also, we have this natural gas data that shows how much residential and commercial use of natural gas for things like heating and cooking we're changing on a daily basis. So all of this data was assimilated and ingested into our ultimate estimates of how these emissions were changing on a daily basis. And it was pretty exciting because, as far as we know, no one had ever done this. People had, of course, tried to make rough guesses of what was happening quarterly, but no one had tried to actually look at the daily cycles of emissions in different countries. And so we wrote up these results and ultimately published a paper reporting them in October of last year. And these are some of those results. So you can see here in the upper left what we thought was happening daily. In 2020 is the bold line in each of these panels. The lighter line is in 2019. And all of the data in these particular figures only goes through the first half of the year because we wrote it around that time. But what we saw was some interesting things that hadn't necessarily been well known. First of all, we could see that the timing of emissions decreases in 2020, as you might expect, corresponded very well with the timing of lockdowns or other public health restrictions in these different regions. And in the case of countries that actually had national lockdowns, those are indicated on these in these shaded gray. We also, though, saw that in China, for example, where the pandemic was brought under control relatively quickly, emissions were already back to 2019 levels by May of 2020. Some other things not necessarily related to the pandemic, even in the 2019 data, we saw something that, as far as I know, no one had ever really bothered to check, which was that there's a seasonal cyclicity to emissions, and that in the springtime in particular, we saw relatively low levels of emissions in most countries. In most places, at least in the temperate latitudes, that's a time of year where the temperatures are increasing, there's less heating demand, there's not many major holidays, and it's not really a vacation season. So for all those reasons, emissions tended to be low then. That said, we did see in different countries, the major holidays that are celebrated in those countries seem to be notably low in terms of their emissions. So these were all interesting findings that came out of this. We also, besides looking at regional differences, we have this data for major sectors, as I've pointed out. And so we saw, for example, that there were modest decreases in 2020 emissions from the power sector and from industry, but that the really big decreases happened, as you might expect, in transportation. And that included transportation on roads, which is the green here, as well as aviation, which saw huge decreases in spring of last year, in many cases that have persisted. And those are in the bottom, domestic and international on the left and right, respectively. At the same time as we wrote this paper and ramped up this new data product, we launched a website that has some visualizations of all these different regions and sectors that you can check out and compare 2020 to 2019. All the data is freely available. And as of this morning, we have estimates that are current through the end of February of 2021. So, not perfectly real time, but pretty recent data. Certainly much less than had been historically the case. And now we have this full year of 2020 data, and we have a paper in review showing what happened in the second half of 2020, which is that by the end of the year, emissions were pretty much back to where they had been in 2019, despite, of course, still very high numbers of new cases globally of COVID. A few other things that I wanted to mention that came out of this new data set, some other papers that we've got in review now. One was that we observed that besides just the activity levels of, say, transportation decreasing and therefore emissions dropping, we actually saw a change in the carbon intensity of electricity generation in many regions. And so carbon intensity means the CO2 per kilowatt hour of electricity, let's say. And so we think that these decreases in carbon intensity are related to both a decrease in the level of electricity demand, but also in the timing of that demand. So let me explain. First, this figure here shows the stack of colors here is different types of low carbon electricity and the share that they represented of total electricity production around the world in comparison to fossil fuels with the bold black line and coal in particular in this dashed black line. And what we saw in 2020 was that perhaps for the first time, electricity from these low carbon sources represented a larger share of total electricity consumed than coal. So this is something that obviously would translate into lower CO2 emissions. And in part, we think that's because if there is a downturn in electricity demand, the solar panels and wind turbines are going to continue to operate. Their marginal costs of operation are near zero, whereas if you have a coal-fired power plant, you can turn that down and save money on fuel. So we think there was a priority where it was possible to cut back on fossil fuel operation. But the other one that I wanted to mention is this timing idea. So these plots are showing you for 3 different regions, including the globe on the left, the electricity demand over the course of a day, and the brownish yellowish dashed lines are showing you the weeks before the major lockdowns began around the world. And the bluish purplish lines are showing you the weeks after that lockdown. And what you can see is that if you focus, for example, on this panel in the lower right, the US, that typically in the weeks prior to the lockdown, there was a pretty sharp peak in electricity demand relatively early in the morning, around 9 a.m. And that was the case globally too, a little later in Europe. But that after major lockdowns went into effect in late March and early April, we saw that the peak in the morning kind of went away. And instead we had this sort of lower ramp up in electricity demand and a peak that was more centered in the day. The reason this might be important is that, of course, to the extent that we have more and more solar power around the world, this means that the peak electricity demand is better aligned with solar noon. And so it could be that we were able to use more of the solar power than we had been prior to this. At least this is our hypothesis. So this was some interesting stuff that came out of the data product as well. Another one that I'll mention before moving on is that we've taken a hard look at what happened to road transportation emissions over the course of the year, and just showing that in 2 figures here. What you're looking at in each of these panels is the red and purple curves represent the prevalence of COVID-related deaths and cases of COVID, respectively. The colored bars show the level of stringency in terms of public health restrictions that were in place in France and the US, respectively. And then at the top, you see the thin line is actually the emissions from the road transportation on a daily basis. But what we've done is plotted in this bolder bluish line the average for weekdays, and the dashed line represents what was happening on weekends. And I think that the interesting thing for me on this is that we saw, at least in the second wave of infections in France, although they did increase the stringency of public health restrictions, the weekdays seemed much less affected than they had been during the first wave of the disease. whereas weekends, again, fell down quite a bit. This is really interesting because it suggests that at least by this time of the second wave in Europe, people were continuing to do the traveling that they needed to do for their work, but they were abiding by the public health restrictions and staying home on the weekends. And that's something that we just wouldn't have been able to see if we didn't have these daily estimates. So interesting stuff. Obviously, a different situation in the US where we really have had a lower level of restrictions than what was in place in France, at least in the spring of last year, but they haven't really ever gone away. And so what we saw was a more steep drop off and then just a gradual easing back over the course of the year. So going forward, this carbon monitor project is going to try to become even more accurate and use even more resolved and independent sources of data so that we can cross-validate and make some robust estimates of uncertainty. One example that I'm particularly excited about is a collaboration we're doing with a company in France called Kairos. And just to give you a sense of the idea here, this is a company that uses a lot of remote sensing data to estimate activities on the planet. Here we have just a picture from a satellite of a steelworks in France. The area of the plant is outlined in this dashed white line. And in these blue rectangles are blast furnaces that are used to smelt iron ore. And so with a different satellite view, we can actually see thermal and optical properties that are being affected by the heat of those blast furnaces. So the red is when those furnaces are hot. And you can see in February of 2020, they were both operating. But during the lockdown in April, we can see that one of these furnaces has been idled. So essentially, we've developed a pretty good number of locations for facilities like this around the world. And we can use this kind of approach to survey those different facilities on a daily basis and estimate an industrial index that's independent of any data that's being collected on the ground. And so this is an exciting opportunity to really advance our data set and have some industrial data in this case that's daily and very specific to the sector and the region. So now I'll turn my attention to a brand new product that actually we launched the website this morning, and I'll tell you more about that in a second. But essentially, we've gone from the national level and for the first time now have estimates of state level emissions in the US. And so just to give you a sense on these maps here, this is not our estimate. There's an Oxford group that estimates the stringency of public health policies, and this is their data. The hotter colors of the reddish ones are indicating a more strict set of public health policies during 2020. And then these other two maps are our state level estimates of the changes in emissions in the middle, total emissions, and in the right, road transportation emissions during 2020. So the cooler colors are ones that had larger decreases in 2020. And I think even here you can already see some patterns. The larger decreases in road transportation emissions and total emissions for that matter tended to be in areas like you see here in these plain states where there's not as much transportation emissions, generally speaking, and they tended to have less stringent public health policies. And that's evident even in these maps. Of course, we've made these daily estimates for each state as well. And similar to what I said, you can see a lot of differences across the states. So in the US as a whole, emissions were down by about 10% in 2020. But I've shown here some of the bigger decreases, relative decreases in other states. Places like Hawaii that really had a lot of tourism, and so a lot of aviation emissions associated with that state had a big decrease. But then other changes like in Montana where transportation wasn't necessarily affected, we actually see that emissions in 2020 weren't that different than 2019 during this spring first wave of the pandemic, but the power sector emissions earlier and later in the year were actually substantially less, just based on what was happening on the ground there. So really interesting differences can be observed at this point. And as I mentioned, we've launched this on a website as well and have these state and sector specific estimates of emissions that are current through the end of February of 2021. So if you're interested, check it out, see how your favorite state is comparing to others and how it's doing in 2021 so far. I can tell you that nationwide emissions are 3% higher already in the first 2 months of 2021 than they were in the first two, which were unaffected by the pandemic of 2020. So we're bouncing back. Underlying the decreases in emissions in 2020 in the US are multiple factors. And I think it's important to notice that on here, we see these annual changes relative to the first quarter of 2019. We see that GDP had been increasing over this period of time since 2016, and that the pandemic really has been a shock to the economy. So that's a lot of the decrease. But we also see some signs that the carbon intensity of energy, as I said earlier, has been decreasing in the US as we switch from coal to natural gas for a number of years, and that's continued. So some of the decrease that we saw in 2020 is probably related to that long-term trend, independent of the pandemic. Specifically, as I mentioned, electricity, the natural gas boom that we've seen in the US has really meant that natural gas has taken a lot of market share away from coal in the electricity sector. And we sort of see that playing out in 2020. So, for example, in this plot on the top, we're looking at how much CO2 is being produced per gigawatt hour in this case, so a little more electricity than a kilowatt hour. And we see that, among fossil fuel burning power plants, that carbon intensity was lower in 2020 than 2019. This is because we're burning more gas and less coal in 2020. But by the end of the year, we see that it's kind of caught back up. And then if you look down at the bottom in the red curve, we see that the share of electricity from coal in the US indeed was less in the beginning of 2020. But during the pandemic, natural gas producers slowed their production due to the pandemic, and that caused natural gas prices to rise. And we saw this kind of late in the year rebound of coal in the power sector. In the transportation sector, there's some other interesting findings. Mainly, I think, if you look at the bottom panel, these blue bars show you the gasoline consumption in each month of 2020, compared to the blue circles are the gasoline consumption in 2019. So we see this definite decrease during the first wave of the pandemic in passenger vehicles that burn gasoline. However, if you look at these yellow bars, which again represent 2020 with the circles being 2019, but in this case, we're talking about diesel fuel, we can see pretty clearly that those Amazon trucks and deliveries that we've all been subsisting on have continued to roll. And in fact, diesel consumption didn't decrease nearly as much as the gasoline. And that's borne out in the top panel. If we look at how much CO2 is being emitted per mile traveled on the roads, we see that there's been a spike, at least early in 2020, because trucks emit more CO2 per mile than passenger light duty cars. Another interesting thing that came out of this recent study is looking at the residential and commercial sectors. And a lot of people have asked, how has staying at home and working from home changed things? And what we see is that at least when we correct for temperatures, which are really important to this sector because most of the energy is for heating, what we see is that in the case of electricity, for example, here in the top, there was about a 3% increase in the use of electricity in 2020 by residences compared to 2019. But it's more than outweighed by a 6% decrease in the amount of electricity being used in the commercial sector, so office buildings and stores and so forth. So in some sense, the electricity sector would have seen a decrease in demand because of folks staying home. Similarly, on the bottom, although not as pronounced, there's been almost no change in natural gas consumption by residents, residential sector, whereas there has been a meaningful decrease in commercial use of natural gas in 2020. So all of this is really leading us to be able to, not just in the case of COVID, but hopefully in other applications, start to look at states in terms of how their different policies and behavioral changes affect emissions. So just to stick with the COVID for a minute, what you see on the left here are the states in the US grouped into ones that had less stringent public health restrictions and ones that had more in red. And you can see clearly that those with the stronger policies had a larger decrease in their transportation emissions. This is both road and aviation. At the same time, you see again with the same colors over here that the incidence of COVID in those states with the more stringent policies also, at least by the end of the year, was substantially less than the states that had weaker policies. But interestingly to me, at the bottom, at the bottom, we see that while the decrease in emissions was greater in those states with the more stringent policies, the change in GDP in those states was virtually the same. And so I think this is kind of a nice example of the sort of thing that we could offer going forward to policymakers who maybe are having policies that aren't related to a pandemic, let's hope, but rather policies aimed at reducing emissions. We could start looking at how those policies maybe affected GDP versus how they've affected emissions and comparing across the states. Excuse me. So, I would say that essentially we've been steering by looking in the rearview mirror. By waiting until the end of the year or midway through the following year to get a sense of what emissions have done, we've really handicapped our ability to be agile in making changes to our policies. And what I mean by that is that if you're a policymaker and you impose a policy that's meant to change emissions, if you have to wait 2 years to find out if that policy worked, that's really going to delay how quickly you can make adjustments to ensure the effectiveness of those policies. So the hope is that by generating these more detailed state level estimates that are in close to real time, we can offer policymakers an opportunity to get some feedback before too much time passes and change policies to make sure they're effective. So as a last slide, I want to pull back and actually say something about the global context of what happened in 2020. And this is from another paper that I wrote with some colleagues from the Global Carbon Project. And we just published this last month. And what we did was take stock of what's happened globally since the Paris Agreement was adopted in 2015. And so these different bars are telling us something about the average change in annual emissions globally in this first pink bar over that period of time, 2016 to 2019. And what we see is that despite the Paris Agreement, annual emissions have been eking up by on the order of, this is about 210 million tons of CO2 every year. And that net increase is really broken into a set of countries whose emissions are increasing still. And then this blue bar is showing around 60 countries whose emissions have decreased over this time period. So, I think this is somewhat heartening that we know that there's a group of countries whose emissions are decreasing. Unfortunately, what we show is that we really need the level of this decrease to increase by a factor of 10. So what we need to avoid, say, 2 degrees of warming on the planet is more like 1.5 or 2 billion tons of decrease in emissions year after year, instead of the 160 million tons that these countries have been doing. Interestingly, and this has been picked up by some folks in the media, the change in global emissions during the pandemic in 2020 was even larger than what we think we might need to meet the Paris Agreement. The key here, though, is that the source of this change is not the way that we want things to go. We certainly don't want the level of disruption and human sacrifice that happened in 2020 every year to meet our climate target. We want to do this in a smarter way that involves transitioning our energy system and changing the structure of how we make and use energy without causing the sort of hardship that we've had this past year. So with that, I think I've left ample time for some questions, but I'd like to thank my colleagues at the Carbon Monitor, particularly Julu and Philip Cias, as well as the whole army of postdocs and students who have helped to develop this data set, and especially a postdoc working with me, Chaopeng Hong, who's really done the heavy lifting on the US Carbon Monitor, which had support from the Climate Imperative Project of the Energy Innovation. So thank you.